Welcome back after the break, and let's continue looking at magnetic declination. Now we've used the example from the pole map, but I'm going to give you a couple of more examples just to make 100% sure that you understand what's being asked from you. Now let's say, for instance, use a map of Durban, and let's use the following information on the middle bottom of the map. Say Durban magnetic declination is 24 degrees, 18 minutes, and the map west, and the map was drawn in 2009. The annual change, the yearly change, is 4 minutes west. Now once again, pay attention to the westerly direction, because what do we do with west? Let's just write it there in a small little block. You can do it west, no, wrong color. West we add, east we subtract. So if you look at Durban, this is just an example. Once you look at the Durban map, it tells us that the magnetic declination for Durban is 24 degrees, 18 minutes west. When they recorded this magnetic declination, it was in 2009. The annual change is 4 minutes west. And then the question asks, calculate the present magnetic declination. So the present magnetic declination will be for the year 2017. So let's quickly do this calculation. First of all, we need to get the difference. 2017 minus 2009. That, go to your calculator. Always use your calculator, because you might make a really stupid mistake and eventually your answer will be incorrect. It's 2017 minus 2009. That gives us 8. And obviously we need to calculate the annual change, how the magnetic declination takes place every single year. 8 times 4 equals, let's go and work our calculator again. 8 times 4 gives us 32. So that's 32 minutes. Now because the annual change is moving west, what are we going to do? We take our magnetic declination, 24 degrees, 18 minutes, plus 32 minutes. So 18 plus 32 gives us 40. It gives us 50 minutes. So our correct answer will be 24 degrees, 50 minutes west. Keep in mind the degrees did not change because our minutes did not exceed 60 minutes. And that's our correct answer. I quickly want to do another example regarding if the annual change would have moved in the easterly direction, just to make 100% sure that you are covered if they do ask this question. Let's use the example of, let's say, Bloemfontein. And on the map of Bloemfontein 1 to 50,000 map, they provide us with the following information. The magnetic declination of Bloemfontein is 24 degrees, 52 minutes west. And the map was drawn up when they recorded the declination was in 2005. The annual change is 6 minutes east. Now grade 12s, please pay attention over here. It's moving eastward, so what's going to happen? It's going to decrease, so we're going to subtract. Now, if you look at the question, calculate the present magnetic declination for Bloemfontein. So what we're saying, 2017 subtracting 2005, because that was when it was recorded. And if we go to our calculator, 2017 subtracting 2005, that gives us 12. Now every single year it's changed 6 minutes, and 12 years has gone by since it's been recorded. So it's 12 times 6. Let's just quickly expand our page. 12 times 6 equals 72 minutes. Now again, grade 12s, 72 minutes equals what? 1 minute equals 1 degree. So if 72 minutes equals 1 degree and 12 minutes. Now very importantly, we take the magnetic declination for the map that was 24 degrees, 52 minutes, and because it moved east, we're gonna subtract. Subtract 1 degree and 12 minutes, because the annual change moved in an easterly direction. So 24 degrees, 52 minutes minus 1 degree, 12 minutes. Let's start with the easiest. 52 minutes subtracting 12 minutes gives us 40 minutes. 24 degrees subtracting 1 degree gives us 23 degrees. So our correct answer will be 23 degrees and 40 minutes west. Okay, the chances that you're going to get a map that where the annual change moves in the easterly direction is quite rare, but please pay carefully attention that this question might be asked. Okay, let's quickly look at our final topic. And what we're going to do with our final topic is magnetic bearing. And what we're basically doing over here, we've basically going to combine what we've learned today. Calculating, determining bearing, using your north-south line from where and to, and use your protractor in the clockwise direction, and the magnetic declination, and we're going to add the two together. Now magnetic bearing, before I'm going to continue, I'm just going to write out the formula. Magnetic bearing equals true bearing plus magnetic declination. Now when we work with true bearing, we work with our protractor and we use our degrees. Okay, and then the magnetic bearing, like we just discussed in the previous couple of slides, when we need to go and calculate it. Let's quickly look what the notes tells us. Magnetic bearing is the angle measured clockwise from the magnetic north. Here the magnetic north is taken from the 0 degrees. As you can remember, the 0 degrees, you place your protractor on your north-south line, and where the 0 is where your magnetic north is. Your magnetic north is taken. True north is taken at 0 degrees. Beg your pardon, where true north is. Now if you look at the formula, magnetic bearing equals true bearing plus magnetic declination. Now let's quickly go and have a look how we're going to do it. Now basically what we're going to do, we're going to combine the two steps of what we've done previously. And we're going to do one calculation. Now if we look at, this is the steps by step, but I will quickly want to go back to our topographical map. And then I will continue with the magnetic declination. Let's assume this map that we see over here, that's the pole map. So just let's fill this in. Pole map, 1 to 50,000. And the question states, pay careful attention to the question. Calculate the present magnetic bearing from Trick beacon 162 to Trick beacon 177. Now first of all, Trick beacon 162 to Trick beacon 177. And let's just quickly fill in the magnetic declination on here. The magnetic declination, let's just quickly add it over here. The magnetic declination for the pole map is 24 degrees, 52 minutes west, and the map was drawn, let's say 2006, and the annual change, let's make it 5 minutes west. So now the question states, calculate the magnetic bearing from Trick beacon 162 to Trick beacon 177. Now first of all, what's the formula? Magnetic bearing equals true bearing plus magnetic declination. Now what do we need to do? True bearing. We're going to need to go and determine the true bearing. And how do we do that? What's our first thing that we need to do? We go and draw a north-south line and a line from where and to. What's our second step? What's our third step? Using our protractor, placing it on our north-south line and starts measuring clockwise. So the 0 shows to the true north. So we're moving clockwise direction. That's 180. Move your protractor in a clockwise direction because you're measuring clockwise. As you can see, from 0 to, that looks like 80. So 180 plus 80 equals 260. So our true bearing, we've just calculated, there's our true bearing, is 260 degrees. How did we do that? We needed a true bearing from Trick beacon 162 to Trick beacon 177. Drawn a north-south line, draw a line from where and to, place our protractor, our 0 degrees on the north-south line, moving around clockwise, and we got our answer of 260 degrees. So what's left for us? We need to go and calculate our magnetic declination. If we look at our magnetic declination, it's 24 degrees, 52 minutes west. The annual change is 5 minutes west. We need to calculate the present magnetic bearing. So what do we need to do? 2017 subtracting 2006 and 6. That leaves us with 11. The annual change that took place was 5 minutes west. So we looked at west. Because it's west, what we're going to do, we're going to add. If it moves in the westerly direction, we're going to add. So 11 times 5 equals, just rather safe than sorry, 11 times 5 gives me 55 equals 55 minutes. Because it's moving in the westerly direction, what are we going to do with the magnetic declination? We're going to add this 55 minutes. In this case, it's 24 degrees, 52 minutes, plus 55 minutes. And that equals. Let's just add the minutes together. 52 plus 55. 55 plus 52 equals 107 minutes. Now, how many degrees is in 107 minutes? Now, 60 degrees, I'm going to write it over there, equals 1 minute. So if we subtract minus 60, we are left with 47 minutes. So 107 minutes equals 1 degree and 47 minutes. So it's basically, the correct answer is going to be 25 degrees and 47 minutes. That's the magnetic declination. Now let's move back to our formula. Just continue just writing it nice and neat over there. Just extend the page a little bit. Magnetic declination, now magnetic bearing equals true bearing plus magnetic declination. And our true bearing was 260 degrees. And what do? We add 25 degrees and 47 minutes west. So what's our correct answer? 260 plus 25 degrees 47 is going to give me 285 degrees and 47 minutes west. And that will be the correct answer for the magnetic bearing from Trichbeacon 162 to Trichbeacon 177. What did we do? We determined the true bearing, we calculated the magnetic declination, we've added the two together, and we got a final answer. That's all that we have time for today. Thank you for watching. I hope you've learned something. I'll see you next time around. Cheers.